So now we're into lesson 3, measures of spread. So these calculations will tell us how spread apart the data is, how variable it is, so how close each data point is to itself. So we'll start with the first formula, standard deviation. So the standard deviation, the formula is here, and it looks pretty brutal, and it kind of is. The square root of the sum of x minus the mean over the total number of data points. So what this means is that we have to add up the sum of every data point subtracted from the mean squared and then keep going it on. So it looks weird, but it'll make sense when we give an example. So here's our data, 3, 5, 6, 8, 9, 0, 1, 0. And then I'll show you how to apply it to the standard deviation formula. So before you can do the standard deviation, one of the things you need to know is the mean. So we have to go back and use our mean formula, the sum of x divided by the total number of points, and we calculate it so it equals 4. And now we can do the standard deviation. So every data point has to have the mean subtracted from it and then be squared. So the first data point, 3, take away 4 squared, plus the next data point, 5, take away 4 squared, and so on. And we continue until we've gone all the way to our last data point. And now from this point, solving it is just a matter of using your old math skills, bad math. So you got to do your exponents first, then you add them up. So we get down to 88 over 8. So then you have to do your division equals 11. And the final step is always going to be taking the square root. So when it all works down, the final answer is that the standard deviation is 3.31. So the way we interpret this standard deviation is we look at how big the number is. So this standard deviation, the number is only 3.3, so it's kind of small, which means that the data is not very variable. So we can look at it and we can see that it doesn't really change that much. All the points are kind of clustered close together. There's nothing huge in it like 300 that would throw it off. And that's that. Okay, so the next thing we have is the quartiles. So the quartiles are kind of like the median, except they don't divide the data in half like the median do. They divide them into quarters. So you have one called Q1, the first quartile, which is the 25% mark of the data. And the other one is Q3, the 75% mark. So the way you calculate it is the same way you calculate the median. You line all your points up from smallest to largest, and then you find the median. So we have an example. So with this data, we line all the points up from smallest to largest. Now the median point is 3. So we put a dividing line through the median, and now to find the 25% mark, you find the middle point from the lowest data point to the median. So in this case, it's 0. And then to find the third quartile, you do the middle point from the median to the largest data point. So in this case, it's 6. And there's a different calculation that you can do called the interquartile range, which is Q3 minus Q1, and that's another measure of spread that we use. So using the quartiles, we can actually make a graph called the box and whisker plot. So the box and whisker is pretty simple to make. You put a line at the median, you put a line at the first quartile, and a line at the third quartile, and then you form it into a box. So that's your box right there. And the scale you're going to use is going to be a scale that allows you to encompass all your data. So this one, the lowest point is 0, the highest point is 9, so we have to go from 0 to 9. We don't just put the data points on it, we make an actual scale that goes all the way up. So once you have your box that's composed of the quartile, the median, and the third quartile, we draw a line from the third quartile to the maximum point and put a little X. So those are your whiskers. And then we go do the same thing where we draw a line from the first quartile to the lowest point and put an X. Now in this example, the first quartile is actually the same as the lowest data point, so the X goes right on the box. But in other examples you'll have a long line extending out to an X, just like you have here. And that's the measures of spread.